Welcome to PGS Maths. This is a quick video requested by user Elite Boxhead on how to prove that recurring decimals can be written as fractions. If we look first at 0.1 recurring, we know that this means that we have 0.1111111 and so forth. If this wasn't recurring, we could just say that this would be 1 over 10, but that would be ignoring the rest of the recurring decimals. So what we need to do is somehow find a way to get rid of everything else after the recurring 1. Using algebra, we can do this quite easily. Our recurring decimal is 0.1, recurring, using the little dot to show what number is being repeated. If I multiply this recurring decimal by 10, I would have 10r and everything would move left one place. So I'd be left with 1.1. All the rest of the numbers are 1, so the ones here are still recurring. The difference being now that I've got a whole number here. If I find the difference between these two values, I'll be left with a whole number, because all of the recurring ones will cancel each other out. So we take 10r and we're going to subtract r. So we start with 1, take away 1, take 1, take away 1, 1, take away 1. So after the decimal point will be 0. Our recurring decimal has been cancelled out. 1 take away 0 is 1. So if we simplify this, we're left with 9r equals 1. In other words, if 9r is equal 1, we can divide by 9 to find out that our recurring decimal is actually written as 1 divided by 9, or 1/9. The same thing can happen when the recurring decimal is not straight after the decimal point. Again, we'll use r to represent our recurring decimal. 0.04, and that dot goes only above the 4 because the 4 is the only one repeating. If we find out what 10r is this time, all this does is move our recurring decimal left one place. All the numbers after it are still 4. We haven't got a whole number yet. We could cancel this out, but then we're going to end up with a decimal answer in a fraction. If we multiply it by 10 again, however, to get 100r, we end up with 4.4 recurring. Now we have a whole number with a recurring decimal after it. The same recurring decimal can be found in 10r, so if we find the difference between these two this time, we'll end up with a whole or an integer value left over. So this time what we'll do is take 100r and subtract 10r. The recurring decimals cancel each other out, so every 4 that's after here will be cancelled by every 4 after this. Those two 4s cancel each other out, and all that's left is to find the difference between these two values. 4 take away 0 is 4. So simplify our results. 100r take away 10r is 90r, which equals 4. And therefore if we divide by 90, we'll be left with our recurring decimal again, which leaves us with an answer of 4 over 90. This can be simplified to 2 over 45. In its simplest form, either answer is proof that 0.04 recurring can be written as a fraction. So what happens if we have two numbers which are recurring? You will follow the same pattern no matter what, always trying to get the recurring decimal cancelling itself out. So this time our recurring decimal is 0.1212, etc. With the 1 and the 2 constantly repeating themselves. What does 10r help us at all? Probably not, but it's worth trying anyway. Multiply by 10, everything moves left one place, so end up with 1.212. Apologise, for some reason the pen keeps joining up. So we haven't got anything in line this time. Nothing can be cancelled out yet. So again, on with the next step to 100r. A 100r means everything moves left another place, so this time we end up with 12.12, with the 1 and the 2 recurring. If we look, we can see that the 1, 2 recurring in our original decimal is now recurring after the decimal point in this one. So this time we can find the difference between 100r and r. The recurring decimal cancels each other out, so 12 take away 0 is 12. So what we have here is 99r is equal to 12, so our recurring decimal can be written as 12 over 99. Here is proof that it can be written as a fraction. We can also simplify our answer by dividing by 3, which will give us 4 over 33. One final example. You could try pausing here and having a go, or just follow through the final example. This time we've got a 1 at the beginning. The 1 never repeats, but the 2 and the 3 do. Recurring decimal is written as 1.23, with the 2 and the 3 recurring. Try 10r. Does that help? 12.323, etc. So far hasn't helped. Go to 100r. This time we get 1, 2, 3.23. So again, it's the 100r and the r which gives us the same recurring decimals. This time I'm going to skip out the step where I wrote down the calculation. We're just going to take away r from 100r to give us 99r. 123 take away 1 is 122. The recurring decimals cancel each other out, so this time we're left with r equals 122 divided by 99. You could leave this as an improper fraction or return it to being a mixed number. If we take away 99/99ths, we've got one whole number, and we should be left with 23 over 99, which is our final answer.